Hello everyone. Let's start today's lecture, and it starts from the point where we have left in the previous video lecture. In the previous video lecture, I have given this you as a homework to try, and many of you have done this correctly. So let me explain the way, the method that we use to solve any problem related to the Newton's laws of motion. Let me first recall you there was a strategy that we have decided. What is the strategy or some working point you can call that? The first point is that you are going about the system. So first you decide about the system which you are want to solve, for which you want to write the Newton equation. And then next point is to draw the free body diagram of that system. That system can be a single particle, maybe collection of particle, or maybe any for that matter. And go for writing all the forces in FBD, and then write those forces in component form. So make the two components of forces. If there's a three-dimensional stuff, so make three components: Fx, Fy, Fz. So you make the components of forces. And then next step is to write the Newton equation, that means F equal to ma. And when you write this F equal to ma, you need to write this in all the directions, like X component separately, Y component separately, Z component separately. Or you can write in one go, that means using the vector equation. So either use the vector equation or you use in component form. So writing the vector equations, then you will find equations. Sometimes you might also require, if there's more than one particles and they're connected, then you might require the constraint relation to write. So also write the constraint equation or constraint relation that is needed in that particular equation. Then you'll find sufficient equation, then you'll find sufficient equations coming in. And then you'll find you need to solve those equations. So you need to solve those equations that you have got. And after solving that equation, you can get your answer. So these are the points or the way to work for the problems related to Newton's laws of motion. So we need to follow this. And here you will see we are going to follow these things, and finally we will get our answer back. So let me explain how this works, and you need to observe each and every step that I am taking over here, and they will be following this method. Now, sometimes it will be easier, sometimes it will be complicated, but overall idea will remain the same. So let's say proceed with the solution. And our focus is to find the tension in the string. And when you are applying this force 60 Newton, this M1 and M2 argue the system is going to move. This is going to move in this direction. M1 will be moving as well as M2 will be moving. So we can start with drawing the free body diagram of different parts. So let's say we are working first in this way, that we are drawing a free body diagram of individual particles. So first we are considering M1 our system. So we are considering M1 our system. That means we will be looking for M1 and writing all the forces acting on M1. So I'm going to call it as a free body diagram of M1. So let's draw free body diagram of M1. Here I'm drawing separately. Later on you can start drawing in the figure itself and quickly write equations. So you will make speed once you have got to know what to do. Okay. So what the free body diagram of M1 or how it is going to look like. So you just draw the particle or maybe just like a point, and then see what the forces this is subjected with. This is a 60 Newton that is acting. It's a visual. And then you'll find that there's going to be a mg force, so that's going to be m1 into g. There are going to be normal reaction coming from the ground, that is contact force, so you can write it as n1. So you have written this contact, then you see, is there any other contact? Yes, there is a contact with the string, so string is going to apply a force. So string will applying a force at this point, and string is pulling toward the string. That force will be tension. So these are the forces that will act on m1, so that becomes the FBD of m1. Now you can see what the forces in nutshell. You can see the forces in nutshell in the positive x direction. If you draw the components, so 60 is 60 I cap minus t I cap. So I cap is in x direction, so that means you can say 60 minus t. Why we have said that? Because I have reversed it. whenever you reverse any direction, there is come a minus. So that's why we need to apply a minus. So this is total force in the x direction. Similarly, we can write total force in the y direction, which will be N1 minus y minus M1G, because M1G plus M1G minus J cap, so that minus is there. Or you can becomes the free body diagram of M1. Now we need to write, so what we have done, we have identified system, we have written FBD, the components of forces. Then after we will be using the Newton's law for x direction and for y direction. So let's talk about the x direction. Now in this x direction, this particle, this M1 will be moving. So there is a acceleration. So let's call this acceleration is A1. If A1 is acceleration in the x direction, so equation will be Fx, net force in the x direction, is equal to mass of the particle or system into acceleration of that system in that direction. Now total force in the x direction you can see from there, which is 60 minus t, that is the total force or net force in the x direction. So we are working for x component, right? And m1, which is a mass, that is given as a 4, a1, which is unknown, this we have to solve. So we can call it as equation number 1. Now in this equation you will find a1 and t, two unknowns are involved. So we need to have one more equation in a1 and t2 in order to solve both. So this is x component of motion. Now we will see what is a y component of motion. So we need to see what happens in the y direction to this particle. Then you say it does not move in the y direction. Since it is not moving in the y direction, so acceleration of the y direction is 0. So net force must be balanced. So from here we can say this N1 must be equal to M1G, because N1 minus M1G must be equal to 0. So that's another equation is coming. If you want, you can use this equation. Now depending upon the question, if the numeration is being asked, so you can use this equation. Similarly, we will go for the next particle and draw the free body diagram, FBD of M2. Now first of all, you think why we need the second block as well to draw the FBD, because here the T is coming and A1 is coming, so there are two unknowns. This equation, if you call it as the second one even, so this is not going to help in solving T and A1. So we need to go for another FBD as well. So let's draw the free body diagram of M2 and draw all the forces that will be acting. So you'll find it will be subjected with the M2G downside, that's a non-contact force, gravitational force, and there will be normal reaction coming from the ground, you can call it as N2, and then there will be a contact force, this tension. So at this point tension is going to pull it like this, and the tension will be the same because the same string, so whatever the T was for the first second will also have the same T. Now this for this you can think of this is going to move in the forward direction, let's say with acceleration A2. So this will also supposed to write equation in x direction and y direction. If you write the equation for y direction, then you'll find N2 will be equal to M2G, because no motion in the y direction, hence forces are balanced. So we are writing the y direction equation. We need to write the equation in the x direction. So for this block, you will find again we will write Fx is equal to mass, which is m2, acceleration a2. What is the net force acting in the x direction? You see there is a t force acting in the x direction, and that is in the positive x. So we write that the t is equal to m2, which is 2, a2, which is unknown. So this is another equation. You can call equation number 2. I am selectively calling the equation. This is as a 1, this as a 2. I'm not giving the name to these equations. You can give the name as well, because our interest is not in the normal reactions. Now again you will say this equation is in t, the same t is coming. However, a2 is another variable is coming, so that means there are 3 variables for us. And if we want to solve, then we need to find a relation between a1 and a2. So once you think about like, is there any relation between a1 and a2? If it is moving with acceleration a1 and this is moving with acceleration a2, they are connected with a string. String is inextensible, so you can say by common sense that both the acceleration must be same, equal, right? And or otherwise you can say, you can write the constraint relation, because you have understood how to write the constraint relation. Now since this is simple, here it will be easier to identify that a1 equal to a2. If there are complicated relation, so you go for constraint relation in case of a string block system. and that's a summation of t dot a equal to 0. So I'm writing it as well. When you do this, then you need to write the for the first. Now you see for the first t is this, a1 is this, so they will be having 180 angle, so it will become minus t a1. Why minus t? Because cos 180. And come to the second, they are in the same direction, so cos 0, it becomes ta2 this equal to 0. Of course, the third equation is going to be a1 equal to a1 equal to a2, and that could have been identified directly as well, that a1 and a2, they are going to be equal. Moreover, you can call it as a third equation. So now you got 1, 2, 3 equations, 3 unknown. What are the 3 unknown? Acceleration a1, acceleration a2, and tension. And you are supposed to find the tension. So by solving these equations, you can find the accelerations and tensions, and also you can find the normal reactions that we have already written over here. So that means the complete solving of the question is done. You will be asked any of the question based on the question, any of the parameter can be asked. So first we did identify system, then we went for FBD, then we went for component of forces, then we went for F equal to ma, then we went for writing constraint relation if any, and then now we need to solve it. Now if you solve it 1, 2, 3 and 1, 2 and 3, then you will get your answer back. Now what you can do, you can assume, let's say since they are equal, you can call that as a it will work. So for first and second, they will be like this, 1 and second, they can be like this. 60 minus t is equal to 4a, and t is equal to 2a. Now what to do? You can add, subtract, or do whatever you like with them to get whatever the value you want. If you want a, so add them. If you want t, divide them. It will work. So let's add them. Once you are adding them, you are going to get 60. T and t getting cancelled out is equal to 6 into a. So this will give us the value of acceleration. Value of acceleration is 10 meter per second square. That means both the block will be moving with 10 meter per second square. And now you can put the value of t in any of the equations. So you will find, as now you can put the value of a in any of the equation to find the t. So let's say we place this value in the simplest equation. This is the simplest one. So 2 into 10, that becomes 20 Newton. Now this question could be solved in a single line or two line, but what I am trying to explain over here is the overall strategy. And no matter what the question is coming, you need to think about in this sequence and keep on writing the equations, then solving it. And over the time you will become fast enough, and you will be making quick equations and getting your answer back. Okay, so this is how a question can be solved. Now let me solve the same question by considering a different system as well. So how we can solve? By using a BD of the entire system. So when we use the BD of the entire system, first let's understand. So if you see this this system, this block, this is going to move in the forward direction. This is also going to be move in the forward direction. And since this is an extensible case, then you can think of this is going to have the same acceleration. This is going to have the same acceleration. In fact, you can say this entire stuff is moving with a same acceleration. That means you can think of this is moving together with same acceleration, right? So better would be you consider this as a part of your system. That means consider M1, M2 together and draw the free body diagram of that part. So if you do so, then again we can make equation that way, because a system is your choice. So let's say we are drawing the free body diagram of M1 and M2 together. That means including string everything. That means we are considering that as a system. And whenever we draw free body diagram, we can always write the entire system as a just like a point. We are not requiring that we draw all the blocks there. And let's see what are the forces that it is subjected with. So can we find the forces? There's going to be gravitational force acting. The total gravitational force will be M1 plus M2 into G, mass into G. And there will be total normal reaction coming from the ground to this system. And this system, we need to see the forces. Since this is the forces that are coming from outside, external force. You'll find the external force is 60 Newton. So this is subjected with a force called 60 Newton. That's all. And now this tension and everything, they will become internal forces. So this is your system, and it is having acceleration A. Now we can make the entire system as a single because all elements have the same acceleration. So that's a prerequisite, that's a condition. A has to be same for all the particles of the system. Now we can write in the x direction, the force is equal to mass into acceleration in x direction. The total force in x direction is 60. Total mass is 4 plus 2, 4 plus 2, and acceleration in the x direction is A. You'll find the A value is coming as a 10 meter per second square. So that will give us quickly answer 10 meter per second square is the acceleration. That means entire system is moving by this. Right, and since we need to find the tension, so what we can do, we can go for another FBD now. So let's say now we draw the free body diagram of M2. That means we want to see this M2 separately. Why we are doing so? Because in this FBD, we were not able to write the tension because tension becomes the internal force. So we need to consider such an FBD so that this tension becomes the external force. This is how the thinking goes. Now, if you consider this M2 as your FBD, so this is M2, you'll find M2 will be subjected with a force called tension. And there will be its own gravitational force, normal relation, but they are going to be vertical. And since we are working on the horizontal equation, then you'll find this M2 will also be accelerating with the same acceleration. So for this equation in the x direction is going to be Fx is equal to mass of this M2 into Ax. Now Fx is T and mass of this M2 is 2. Ax is A we have already calculated, right? So what the T came out to be? T came out to be 2 into 10, that is 20 Newton. So we can solve in this manner as well. So my concern or my main point to explain this was that it depends on you what system you choose or which the FBD you are going to make FBD based on the requirement of the question. And if you are making a particular FBD, use that mass and use that acceleration and use the force on that FBD. And then you can write the equation in x direction. You can also write the equation in y direction. I have not written because that's not needed over here, but they can always be written. Okay, so this is overall a strategy. I took too much time for explaining this, but mind it, if you have got to know this strategy, you can apply in all the questions, you will get your answer in all the cases. Okay, let's take a few more examples and try to use the same thing quickly. Let's read this similar type of question. It says 2 blocks of mass 4 kg, 2 kg are placed side by side on a smooth horizontal surface, and there is a horizontal force as well as shown in the figure. We need to find the acceleration of each block and we need to find the normal reaction between the blocks. So it's a very similar type of question and you will be observing. I will be using the same strategy to solve it, and you can pause and solve quickly if you want. So since we need to find the acceleration, so we will see when you are going to push it, then this 4 kg is going to be pushed forward direction. Then this 4 kg is going to further push this 2 kg. And this will be moving forward, this will be moving forward. But you'll find both has to move simultaneously. That means this contact has to be there. So since there is a contact, that means they will be moving like a single body. So better that we take this, this is going to move with the same acceleration A. So we will conclude that they are going to move with the same acceleration A. So first we will draw the free body diagram of system. Of system means everything included. It means 4 kg as well as 2 kg together. So if you draw the free body diagram of these two together, then you'll find it's going to be some sort of this. Let's say this is your the system denoted by a point. It is subjected by a force called 20 Newton, and then there is going to be horizontal vertical forces like weight 2 plus 4, that is 6 into g, that is 60 Newton, and you'll find a normal reaction upside coming, normal reaction, and that's the equation, right? Or you can say that's the FBD, and this will be moving here with acceleration A. So we can also draw the acceleration there. Now quick equations, the vertical direction will say it's not moving the vertical direction, so normal reaction must be equal to 60 Newton. And what is the acceleration? So write equation for the force in the x direction. When you write equation for the force in the x direction, so you write it as a net force in the x direction is equal to mass of the system, acceleration of the system in the x direction. Now what is the total force is coming? That is 20 Newton. That's the only force acting, because this is a single body, so these are the internal force now. And this is equal to total mass. Total mass is going to be 4 plus 2, that is 6 into A. From here you can find the value of A. So what the A is coming, 20 by 6, that is 10 by 3 meter per second square. So first part is done, that is acceleration of each block. Now you will say that this acceleration is of each block because both blocks are moving together, they are in contact. Okay, and this is the normal relation, but this normal relation was not the same normal relation that has been asked. They are asking the normal relation between the blocks, and this is the normal relation offered by the ground to both of the block together or combined together. Okay, so for that matter, or for that purpose, since we are going to find, or we are supposed to find the normal relation between the two, so we need to see either of the two separately, then only we can find, or we can see that normal relation. So next point would be drawing another FBD. So let's say you are drawing free body diagram of any of the two. Let's say I'm drawing now for 2 kg block. So if you draw this free body diagram of 2 kg block, how this 2 kg block is going to look like? Let me show like the block, or as a point, whatever you want, you can do so. So in this 2 kg, you'll find its mass or gravity force will be downside 2 into g, that is 20 Newton. It will be subjected by normal relation from the ground. You can call it as N1, N2 or whatever. And that's all. And then you'll find there is no force acting from any side, but this side is in contact. So this side is going to create a normal reaction, and that means it's going to push because of force. So 4 will be pushing it. So that is normal reaction that is being asked. So let's call it to be N. So this N we need to find out. N is the normal reaction between the blocks 2 and 4 kg. And this is 2 kg block that we have drawn the FBD of, and you will find this 2 kg is also moving with acceleration A. You can also draw the free body diagram of 4, you will get the same answer back, right? So for this you will write the equation. If you want to write the vertical equation, N1 will be there, but we are not interested. We are interested in the x direction. So you write the net force in the x direction is equal to mass of this into acceleration in the x direction. Now what is the force in the x direction? It's normal reaction N. And how much the mass is? 2. How much acceleration is? A. A we have already calculated. So from here you will find the normal reaction will come as 20 by 3 Newton. So this N was for normal reaction, this N was, or there's a Newton, so that becomes your answer. Now this is how you can solve for acceleration as well as for normal reaction. Understood? Now let's take another important simple example. It says in the shown figure, find the acceleration. We need to find acceleration of each block, and we are assuming the pulley is massless, frictionless, and strings are massless, so everything is given to us. So this is the basic combination of string and pulley, and this is also known as Atwood machine. So what we are going to do it for this Atwood machine, we will be making formulas, right? And then we will remember those formulas as factual information after solving it, and that will be helpful to save some time. So let's say this 3 kg that you are saying is M1, so we will be writing in M1 and M2 format, and this is M2. So our result will be in terms of M1 and M2, and finally we can place this M1 as a 3 kg, M2 as a 4 kg to give the answer of this particular question. And if there is any other masses, you can use the value of M1, M2 as per the given in the question, right? So what is going to happen? One of the two will be bigger in the two blocks, as bigger in the sense the weight will be more, or mass will be more, just like a 4 kg, that M2 is bigger. So let me start solving over here. So we will say M2 is greater than M1. So we are taking the case in which M2 is greater than M1. Idea will be drawing the free body diagram, writing equations and the same story, and finding the acceleration. So first of all, we decide the acceleration. Now common sense will say heavier thing go downside, so this is going to go downside with acceleration A2, let's say. Then this has to move upward with acceleration A1. Then you can write the constraint relation. This tension will be upward direction, this tension will be upward direction, this T and T same tension will be there, and you'll find these tensions and dot A1 and A2. If you are doing that, these tensions are on the block, right? So you'll find constraint relation will say A1 equal to A2. Constraint relation will say A1 equal to A2, right? And this can also be thought of because the same string is passing through over this, so it's inextensible, so all points will be moving with the same acceleration. So using that constraint, we can claim that this is going to be A1 in magnitude, this is going to be same magnitude A. So A1 and A2 will be having the same magnitude but opposite directions will be opposite, mind it. So both the blocks do not have a same acceleration, they have a same magnitude of acceleration, so that we need to keep in mind. Now here we can also draw the free body diagram of both the blocks separately or maybe in this picture itself. So let's draw the free body diagram of this M1. If we draw the free body diagram, then you'll find there's going to be a force acting downside, which is going to be M1G. And this is another force that we have already seen is a tension, which is in the upward direction. And these are the only force that will act on this. Similarly, on this, there will be two forces. M2G will be downside because of gravity. T have been already shown there. So these are the two forces acting for M1 as well as for M2. Now, then we need to make the equation. So FBD we have form in the equation itself, and that works. So now we'll be writing the equations of Newton. So let me write the Newton equation for M1 block. If we write the M1 block, here you need to keep the point in mind. We are writing the Newton equation in M1 block for M1 block, right? So since M1 block is moving in the upward direction, right? Hence net force must be considered in the upward direction because we know F equal to ma. So where in the direction of force and direction of acceleration, they are identical. So how to write the equation? For that sake, if you have made the direction of acceleration, then write the net force in the direction of acceleration. So that means this will be in the direction of acceleration. This is opposite to the direction of acceleration. So this will be written as a minus. So this equation will be net force is equal to mass into acceleration. Net force is going to be T minus m1g is equal to mass, which is m1, acceleration, which is a. So that becomes first equation. Now we can write this Newton equation for the second block. Important point you are learning, right? Direction matters, right? So a direction has to be the direction of the net force. Now second is going downside, so acceleration you have made downside, hence net force in the downward direction has to be taken. Now that means this direction, this force is in the downward direction and this force is opposite to the downward direction or opposite to A. So this has to be written as a minus. So we will write net force downside is going to be m2g minus t is equal to mass, which is m2, into acceleration, which is a. Okay, so here we are writing F equal to ma, and since we know the direction of A, so we are writing all the force in the direction of A, and then we are writing F equal to ma. Okay, these are the two equations you can solve. Once you solve these two equations, you can solve for the two things: acceleration for the blocks and tension. So here the acceleration has been asked, and the other question can be asked about the tension, so we can formulate the formula for A and T as well. Now let's add these two together. When you add these two together, you'll find m2g minus m1g, so it becomes m2 minus m1 into g is equal to, here it will be m1a plus m2a, that will become m1 plus m2 into a. So this is kind of a result. You need to remember A is equal to m2 minus m1 into g divided by m1 plus m2 or m2 plus m1. So whenever there is a Atwood machine given to you, or this simple two blocks and pulley system is given to you, you can directly write acceleration by using this. m1, m2 will be given to you, g you know, and you will find the acceleration and the direction you can decide accordingly, and this will become the formula for acceleration. Okay, once you got to know this acceleration, now you put this acceleration back in any of them and you can solve. You'll find the value of t for tension. Check whether you are going to find the value of t as 2 times m1 m2 g divided by m1 plus m2. I have written this directly What you need to do, put the value of a in either of the two equation, simplify for the t, and you'll find this t as the expression. And then these two important formulas, these both becomes very very important to save your time. And whenever there is a pulley system like this Atwood machine, you'll find you can use this directly. M1 M2 will be given to you and they will give you answer. As far as the answer of this particular question is concerned, now you'll find it's going to be quite easy because you know this expression. So what I'm going to write is acceleration is going to have a magnitude m2, which is 4, minus m1, which is 3, divided by 4 plus 3 or 3 plus 4, whatever you write, into g. So it ultimately becomes g by 7, g by 7. And that can be said your answer, meter per second square, or you can say 10 by 7, that becomes your answer, right? So this is how you can get your answer for Atwood machine. Important point, please note it. Now let's take one more example in which this application of Newton's law we are going to see. It says find the acceleration of each block, and m2 is eta time m1, that has been given to us, and the masses of pulleys and threads are, as well as the frictions, are assumed to be negligible. So this is a story. This is a fixed wedge, and on this there's a pulley mounted, and there's another pulley, and this is m2, this is m1. So what we are going to do, we are going to draw the free body diagrams, right? So let me draw over there this m2. So this m2 will be having this kind of free body diagram. Let's say I'm drawing it separately. This is going to have m2g downside, no normal relation because it is not in contact with the ground, and there's going to be tension acting upside, that's all. So draw the tension upside, that's a T. Now if this is, that means I have assumed the string this has a tension T. So if this has a tension T, then you'll find this will have a tension 2T. So let's draw the free body diagram of this block M1. You'll find this M1 will have a tension along this string and pulling. So that will be 2T tension. Makes sense? And it will have its own mg downside, m1g. And you'll find this mg is going to be made two components, one in the direction of inclined plane, another in the direction of perpendicular to inclined plane. These are the two components I'm making for mg. And there's going to be one more force acting on this because of this contact, and this is going to be perpendicular to the contact and pushing. That means there will be upward direction, that's called normal reaction. So you'll find a in this direction. And this blue colored component of m1 g, so that components will be basically m1 g sine theta. You remember we have talked about along the inclined plane is going to be sine theta because this angle comes out to be theta. So this becomes m2 g cos theta, right? So this represent the free body diagram of m1, in which we will consider the component of mg, that means these two components, and the normal reaction and the tension. And m2 FBD is very very simple. Now what will happen if it is going downside by certain acceleration, let's call this is moving downside by acceleration a2, then this system will be moving upside with acceleration a1. This will be moving upside with acceleration a1. Okay, and we can write the equations in the direction of acceleration, and that will be helpful for us. So let me write equations for m1. So what the equations for m1 is going to be, now in the direction of acceleration, how much the force is acting? Is it twice t minus downside is this m1g sine theta, m1g sine theta. This is the net force acting in the direction of acceleration, right? And this must be equal to mass, which is m1, into acceleration, which is a1. So that's the Newton equation for the block 1. We can also write another equation in this perpendicular direction, and this will say nr is equal to mg cos theta, but if it is needed you can write it. So here the components we made along the inclined plane and perpendicular to this. Then we will try to write Newton's law for the second particle. Second particle is going downside, so we need to write the net force in the downward direction. So it's going to be m2g minus t. This must be equal to m2 into a2. And you will find this is our second equation. Now we need to keep what are the unknowns that we are having. A1 is unknown, we need to find. A2 is unknown, we need to find. And T is unknown. So there are three unknowns. Since there are three unknowns, then you need to know three equations unknowns. So two equations we have got from using by using the Newton's laws of motion. From where the third equation has to come? Then you'll find the acceleration of 1 and 2, they are linked together. They are not independent of each other. So that is going to come because of the constraint relation that we have already understood, right? So constraint motion. So constraint equation will be or relation will be summation of T dot A equal to 0. When you use this, you will get the third equation, which is much needed, and then it can be solved. For the first block, you will find t twice t, and this is a1. They are in the same direction, so it will become twice t into a1 cos 0 plus. When you come to this, they are t and a2 but opposite, so they are going to be minus t into a2 is equal to 0. You can cancel out this t, then you can claim from here that a2 must be equal to twice times a1. A1, A2, they are linked like this. This is third equation. Now what you can do, now you can solve one equation simultaneously and find the value of A1, find the value of A2, and find the value of tension. So all the quantities that are needed can be found. Tension is the T which we have assumed for this string. And if somebody asks what is the tension on this string, then you can think of it's a twice T. So you can answer all the tensions, right? Now how to solve this, we can handle that as well. What you need to do, you need to use 1, add with the 2 times multiplication of 2. So multiply this 2 by 2, then then add it up, right? So this 2t will get cancelled out, and you are going to get some sort of this. Let me write that. It's going to be twice m2g. I have multiplied it by 2, so this 2t is getting cancelled out, minus m1g sine theta is equal to, since you have multiplied it by twice t, so it will be some sort of m1a1 plus 2 times m2a2. Now what do you do? Place the value of a2 in terms of a1. So if you place the value of a2 in terms of a1 using thirds, so that will become basically m1a1 plus 2n2 will become 4 times m2a1. From here you can find a1 value. Can you see the a1 is coming? And moreover, you can rewrite this equation. Let me write over here. When you rewrite it, from here you can take a common g and place this m2 as eta time m1. So this is going to be 2 times eta m1 minus m1 sin theta into g. Makes sense? Is equal to, here also you can replace m2 by eta m1. So it's going to be m1 plus 4 times eta m1 into a1, right? Now you can take this and get some answer out of it. You will find m1 and m1 will get cancelled out from both the side. So it will be some sort of this, like twice eta minus sine theta, twice eta minus sine theta into g is equal to 1 plus 4 eta into a1. Now you will find the value of a1 out of it. So a1 came out to be twice eta minus sine theta into g divided by 1 plus 4 times eta. So that is coming as a1. Once you get a1, you can put the value of a1 to get the value of a2. That means a2 is just twice of this number, right? So if it is just twice of this number, you can easily find it out. And then you can place this value of a1 maybe here to find the t, or maybe here for a2, then find t. So you can solve for the t. I'm just trying to tell you the idea, overall view, and that becomes your answer. And for a1, then you a2, and then t. So in all these questions, you simply go for drawing the free body diagram, writing the Newton equation. Where the attention has to be paid is this: how we are writing the equation of Newton is simply force is equal to mass into acceleration, and force on the object of which mass we are using, that means of which we are using FBD, and the acceleration of the same object or same system, and the force on the same system. Moreover, acceleration direction and force direction has to be identical. So that's what we are using. Okay, I hope it's going to helpful for you. Now there is a homework problem for you, and it's example, but it's a homework for you that you need to solve at home. And what is this situation? This figure is shown to you, blocks and pulleys, everything is ideal. Acceleration of 2m. For this we need to find the acceleration. There are 4 options, so we need to solve this. Just follow the strategy that we have learned, and you will be able to find the answer. There are 4 options, you need to mark the right option. Okay, so in this particular video you have learned about application of Newton's laws of motion, and that's particular strategy, and that's steps that we need to follow and write equation, and you can solve all the problems. Now you can try the questions from exercise and the suggested books. You will be able to solve several of questions on these Newton's laws of motion. Well, so thank you everyone. Have a great time.